Hello, thank you so much for your time. My name is Darlene Fee. This is the second part of the integration by partial fraction fundamentals. Okay, so before we move on to the second fundamental, it is important for us to understand some standard integration. So the first example is a standard integration that we need to know. So the integral of 1 over x plus 2 dx. When you integrate this by standard, you are going to get the natural log of the absolute value. Then whatever denominator you have down, you place inside the absolute value symbol and then plus c. Plus c because this is indefinite integral. That is, the top must be 1 and then the down must be some algebra. And so because I have 1 here and then I have some algebra here, the standard integral is natural log the absolute value of the denominator you have, that is x plus 2, in the absolute value plus c. Then another key important takeaway that we need to also understand is the second example. So the integral of 3 over x minus 7 dx. Now remember, the standard says that the top must be 1, but here we have the top not being 1, it is 3. So in a situation where the top is not 1, it is 3, you have to factorize it to come outside the integral sign. So when I come to this step, you realize that this 3 has been taken out, and if 3 is removed, what will be remaining here is 1. So on the right hand side, you see that the 3 is outside the integral sign, and then we have 1 over x minus 7. Then we can apply this standard integration here. So when you integrate this, it is going to be the natural log absolute value of whatever you have down here. So that is the x minus 7 in absolute value plus c. Now the 3 that you brought outside is going to multiply the natural log. This is another important key takeaway that we need to understand as we move on. Then the last one is this. So we have the integral of 3 over 5x minus 5. Now here notice that the top is 3, and then where the x is, there is another number attached to it. In the first two examples, no coefficients was attached to the x. Here too, no coefficients was attached to the x. Okay, but in this case, there is a coefficient of 5 attached to the x. We apply the same concept as we did in step 1 and in step 2. How do we do it? First, you factorize the 3 out. So if this 3 comes outside, what will be left here is 1. So if you have 1 over 5x minus 5, then if you are integrating that 1 over 5x minus 5, remember, already you have factorized this 3 outside. So when you integrate the 1 over 5x minus 5, you are going to get the natural log absolute value x minus 5 plus c. Okay, so the question is, where from these extra figures? Now this 3 was the 3 that you factorized outside. Remember, here we had a 3 coming to multiply the natural log. So that 3 is what you ought to see here. If this number were to be 6, then this would have been 6. Whatever number you have here, that same number will be repeated here. Then the next question is, where from 1 over 5? Now it's simply so because 1, let's go to the top. When we integrate, when we find the derivative of x, we'll get 1. When we find the derivative of this x2, we'll get 1. But when you find the derivative of this 5x, you will not get 1. You are going to get 5. All right, and so it is going to, because we are going to get 5, we are going to write it 1 over that 5. So this 5 is coming from the differentiation of the 5x. That's how come we got this 5. And so now we multiply 3 times 1 over 5, and we are actually getting 3 over 5, and then we have the natural log of natural log of 5x minus 5, and then plus c. So once you have understanding of this takeaway, then we can move on and then solve the questions that follows. Thank you.